Hello and welcome to Maths with Jacob. This lesson will focus on Pythagoras Theorem. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it. This is quite tricky. Pythagoras. Pythagoras was a Greek mathematician who lived about 2,500 years ago. It is believed that he made one of the most important mathematical discoveries of all time. Before we state the discovery, let us look at a typical right-angled triangle. Now this picture here is a right-angled triangle. I want you to look at this side here. It's the side C, and you can see that it is the longest side. It's called the hypotenuse. It is opposite the right angle. So whenever you want to find or look for the hypotenuse, just go and see where the right angle is, and it is the side opposite the right angle. And the right angle, as you would know, is 90 degrees. Sides A and B are the other two sides, A and B. Pythagoras' theorem. If we look at the picture to the right, Pythagoras said the following: the area of the red square equals the sum of the areas of the blue and grey squares. So the sum of the area, or the area of this square, if you work out the area of this red square, it is equal to the sum of the areas of this square and this square. Now, I've stated this another way diagrammatically. This red area here, the area of this red square, equals the area of this blue square plus the area of this grey square. That's Pythagoras' theorem in a diagrammatic form. That is, in the form of a diagram. Pythagoras' theorem. Another way of saying what we said on the previous slide is the square on the hypotenuse equals the sum of the squares on the other two sides. So the square on the hypotenuse is c squared, and this is the square of one of the other sides. This is the square of the other side, and you add those together. So the square on the hypotenuse equals the sum of the squares on the other two sides. Now that is stating Pythagoras' theorem in an algebraic manner. That is, using algebra. A simple example. The above example will illustrate how Pythagoras' theorem can be used to find the hypotenuse of a right-angled triangle when we are given the other two sides. Now here is the hypotenuse, x centimetres. We don't know that length, but we know the length of the other two sides. So using Pythagoras' theorem, we are going to work out the length of this hypotenuse. If we follow the theorem as stated, we have the following: x squared equals 3 squared plus 4 squared. X squared equals 9 plus 16. X squared equals 25. X equals the square root of 25. So x equals 5 centimetres. So the length of the hypotenuse is 5 centimetres. Another example. The above example will illustrate how we find an unknown side when we are given the hypotenuse and one of the other sides. So here is the unknown side here. We are given the hypotenuse and one of the other sides. If we follow the theorem as stated, we have the following: m squared plus 8 squared equals 10 squared. M squared plus 64 equals 100. Now remember, we have to solve for m. So what we do here, we subtract 64 from both sides. That's how we solve this equation. Because that's a plus sign here, so we do the opposite and subtract 64 from both sides. When we simplify this equation here, we have m squared equals 36. M equals the square root of 36, so m equals 6 centimetres. So the other unknown side is 6 centimetres. A quick quiz. This quick quiz will help with your understanding. Please check through the video if you need to do so. Puzzle 18 answer. What is the meaning of the following? And the answer is lucky break. It is a little bit tricky, isn't it? Well done if you got that one out. Quick quiz answers. As always, feel free to check through the video at any time to help you. If you enjoyed this video, please subscribe on the next slide and you will receive a notification as to when the next video is available. Hope to see you next lesson.